Here we've got another question on density, and this time we're trying to choose the right volume or mass of two materials so that we get this sort of this target density of 0.6. So let's start with looking at what happens to the sort of the average density. So let's say we have a fixed volume. Let's call it 1 centimeter cubed or something. At the moment of B, at the moment that the average density is clearly 0.2. So we need to get it higher. Let's try adding a little bit of A. Now at this point, the average is 0.45. So we need to add more A. And instead of becoming 0.45, the average now becomes 0.5. I'm not there yet. Let's add a bit more A. If you do the calculation, it goes up to 0.55. Nearly there. You'll see there's a pattern emerging. Now, if I have 4 amounts of A to one amount of B, that adds up to 0.28, 0.3 altogether, and we take the average and we get 0.6. So the point here is that we need 4 times as much A as we do B. Now that can be summarized a little bit more clearly if I just look at the difference between these two values. The difference here is 0.1 and the difference here is 0.4, and therefore you can see that for these two amounts to kind of be equal, I need 4 times as much of material A than I do B. Now the amount that I've got to have is 100 centimeters cubed, so this becomes a ratio problem. I'm going to share 100 centimeters cubed in that ratio 4 to 1, so it becomes 80 and 20 centimeters cubed. To work out the mass is quite simple. I multiply the density by the volume, and that gives me 56 and 4. And you'll see that the total mass is now 60 grams, which gives me the target density of 0.6.